So today we are going to start a new topic called the calculus of variations, which is popularly known as the COV. So from the CSIR NET point of view, it's an important topic because in every year's question paper there will be at least 2 questions from this topic, either both of them in the B part or one in the B part and one in the C part. It is comparatively an easy topic because it has less content and we will have to remember some formulas and stuff like that. So in the first lecture we will be understanding what COV is about, what we have to actually do, and in the upcoming lectures we will be getting introduced to the equations that we use, and we will be solving some previous year questions and some special cases of the problems. Okay. So in today's lecture, let's get started. Okay. So as you can see here, 2 points x1, y1 and x2, y2 is given. And what we have to do is that we have to find a curve y between x1, y1 and x2, y2 that will either maximize or minimize, that is, we can generally say extremize this integral 1, that is I equal to integral x1 to x2 f of x y y dash dx. So we have to find a y between x1 y1 and x2 y2. We have to find a curve between x1 y1 and x2 y2 that will extremize this integral. Okay. So to write that the curve is between x1 y1 and x2 y2, we can mathematically write it as y of x1 equal to y1 and y of x2 equal to y2. So this condition is usually known as the boundary condition. Okay. Now let's get introduced to some basic terminology. So here this function f of x y y dash, this is a function that depends on more than one variable, right? Here x is a independent variable, y is dependent on x and y dash is also dependent on x. This function is it could be like something like x plus y dash. Okay. So this is an example for f of x y y dash. Okay. So this is a function that depends on more than one variable, right? So such a function that depends on more than one variable is called a functional. So a function which depends on more than one variable, a function which depends on more than one variable is called functional. Rather than calling it a function, we could call it a quantity also, because a functional always assumes numerical values. Okay. So that is the first term that we are dealing with, a function or a quantity which depends on more than one variable is called a functional. Functional always assumes numerical values. So here not only f is a functional, but I is also a functional with fixed endpoints x1 and x2. If either of x1 or x2 is varying, then it won't be a functional. But if x1 and x2 are fixed, then I is also a functional. Okay. So that is the first word, the first term that we are defining. Okay, to the next one. So here what are we doing? We are finding a y between x1 y1 and x2 y2, that is extremizing this function, this integral, right? So such a y that will extremize this integral and satisfies this boundary condition is called a stationary curve, or extremal. So a y that satisfies the boundary conditions and extremizes the integral is called the stationary curve or extremal. And the value of I corresponding to stationary curve is called stationary value or extremum. Okay, extremum. Okay, so what we are doing in COV is we find a curve that extremizes this integral and satisfying these boundary conditions, and when we get such a y we put it here, right? We put it here and we find the extremized value of I, and such a value is called the stationary value or extremum. Okay, now the next term that we have to understand or we have to define is admissible functions. So here when I said a function between x1 and y1, I didn't mention whether it have to be continuous, differentiable, or smooth or something like that. So in COV, we are only considering those functions between 2 points. We are only interested in those functions which have we are only trying to find those curves between 2 points that have continuous second order partial derivatives or derivative. Okay, so we are only dealing with those curves that have, or those functions that have a continuous second order partial derivative. Okay, such functions that we are restricting ourselves to some particular sort of functions that has a continuous second order partial derivative. So such functions are admissible for us, so we are calling such functions admissible functions. So these are the basic things that you have to understand about COV, and when we are solving questions, you will be asked to find the stationary curve or the stationary value uh, uh, and things like that. So these are the basic terms and definitions that you have to understand. And I believe that you understood what we will have to find in a problem from calculus of variation. So that's it for today's lecture, and thank you for watching.